Remember that if you have alternate interior angles, that kind of proves parallel lines. So what they're saying is draw an angle. So I'm going to get a straight edge, get a compass, and I'm just going to draw this line. You guys got to make that noise too. Okay, good. I know you guys are doing it. All right, good. Draw a transversal. Boom, I got an angle. Okay? So now that I have an angle, I'm going to take my compass here, arbitrarily choose the distance, right? And then what I'm going to do is I'm just going to make a little arc. So to copy that angle, we've been doing corresponding angles, but what I'm going to do now is I'm going to arbitrarily choose a point here, and because it's an alternate interior angle, now I'm going to take and make my arc this way. Actually, I should have done the bottom half. So here's where it gets tricky. If this is like angle 1, then my angle 2 would be here, right? And I would want angle 1 to be congruent to angle 2, and then that would prove parallel lines. Parallel lines. Got a little excited there. All right, so how do I do that? Well, it's the same way I've been doing it. I'm going to take my compass and I'm going to find the distance of this arc. Okay? Now that I have the distance, I know that that distance has to come from here to here. Does that make sense? Go ahead. So now I'm going to make my little arc this way. So I just draw it a little different. So now I'm going to take my ruler and I'm just going to connect those two intersections. Angle 1 is in fact congruent to angle 2 because that's how I constructed it. Therefore, those two lines are parallel. Let's label them so it makes sense. So we'll call this one line L and line M. So we would say that line L is parallel to line M. See how I did that? It makes me feel, it warms my heart to hear the compasses hit the desk after you're done drawing these.
That's all you have to do.
That's it. That's it. Okay? Yes? Yes, you may. All right, let's do the next one. So that's problem number 19.
Easy, I knew that.
Can you give me a pencil real quick?
Yeah.
Can you also get me one? Can I trade this in?
Oh no, the questions aren't to like the
Then
end.
toss Matt's pencil and no, toss the pencil.
Problem number 21. So that's problem number 19. Problem number 21 asks us to pretty much explain how we know that this is a parallel line, right? And so really it says, explain how the converse of the alternate interior angle theorem to construct a line parallel to the given line through a point not on the line. So basically, it's just worded a little different. So this is like my line M, right? And then we have this point here. We would call that maybe point capital N. And we just basically constructed a line through my transversal T such that that line intersected at the point N, such that angles 1 and 2, which are alternate interior angles, were congruent, and therefore, because they're congruent, lines L and M are parallel. And you could write that in your own words. It's not asking for a formal proof. We've already done that. They just want you to kind of write in your own words that since angle 1 is congruent to angle 2, then, and we should probably label that they're alternate interior angles. Since angle 1 and angle 2 are alternate interior angles and they're congruent, then we know that lines L and M are parallel, right? And that's what the converse means. You could go and expand and go further and talk about how the corresponding angles are congruent. In other words, if this is angle 2, then angle 3, right? In other words, angle 2 is congruent to angle 3, right? And then we would say then, since angle 1 is congruent to angle 2, then we can conclude that angle 1 is also congruent to angle 3 through the transitive property of congruence and their corresponding angles. And that's kind of the first thing that we proved in this section, is that when you have congruent corresponding angles, then the lines L and M would be parallel. Does that make sense? Okay.